So, today kita akan belajar 7.3. Kita akan belajar 7.3 intermolecular forces. So, have you guys pernah dengar tak intermolecular forces?
No.
So, there's two things, okay? There's intramolecular and intermolecular. So, intra and inter. Okay. You guys tahu tak internet? We also have, pernah dengar tak intranet? You guys ambil ni kan? Computer science kan? Ada kan belajar intranet is basically you punya net which is just around your system, tak include everyone. Kan?
Sampai
Terang lagi. Okay. So, samalah intermolecular forces. Intermolecular forces only between molecules. Okay. Ahmad, you guys boleh nampak my camera kan? So, this is for example a polar molecular. Contohlah HF. So, hydrogen, the smaller box, the smaller box ni, and then fluorine, the bigger one. So, intermolecular forces is the forces between atoms. So, kalau intra. Kalau intra is between the atoms. So, bayangkan intra is the ni, what is called benang ni. So, if you guys can see, is very strong. So, contoh intramolecular is macam covalent bond kita belajar itu, ionic bonding. Ni ada?
Ya.
Okay. Kalau ionic tu, apa beza ionic and covalent? Ni ada?
Ionic lagi kuat daripada covalent.
Yes. And one more thing, ionic dia derma and terima kan? And covalent dia orang share. Yes. Those are intra. INTRA molecular forces, while yang kita nak belajar hari ni is intermolecular. So inter, it means between other molecules. So macam between HF1 ni dengan HF yang kedua, or maybe dengan HF yang ketiga. So if you guys nak boleh bayangkan why kita separate between intra and inter. Okay, intra tu macam ionic, covalent semua tu kita belajar dulu, and then baru kita nak belajar intermolecular. Sebab the strength are different. So, bayangkan this velcro is the intermolecular forces. So, if you guys can see, kalau I tarik, the first thing yang would break is the intermolecular forces. So, because macam covalent bonding, ionic bonding tu is way stronger than what we will learn today. Okay. So, I got one question for you guys. Kalau you masak air, nanti masak lama dia jadi, lepas dia boiling dia jadi warp kan?
Yeah.
So, what happened to the molecule? Is it H2O tu dia jadi hydrogen and oxygen gas ke, ataupun dia pecah-pecah ke? Macam mana? Apa jadi?
Dia
Okay. Right. You have any idea? So, it's actually what happened. Okay, bayangkanlah ni is 1H2O. So, bayangkanlah dia ada HN 2H and 1 oxygen. So what happened bila you guys boil, okay, you give energy to the system. What happened is hydrogen dengan oxygen tu tak akan berpisah. Apa yang berpisah is 1H2O akan berpisah with other H2O. It will become warp air. If warp air, kalau you guys tengok warp air, you ambil, tengok mikroskop, bukannya individual hydrogen, individual oxygen. It's still H2O, tapi in a gas form. So what happen, nanti kita akan belajar, when you apply heat, the molecule separate. Dia separate with other molecule. Dia bukannya bukannya separate between hydrogen and oxygen tu. Okay, that's the one thing I want to make sure, because ionic or covalent bonding tu is very strong. So using heat, you have to use a very high heat baru kita nak boleh pisahkan this. So ibarat kita kena guna gunting baru kita boleh pisahkan the ionic or covalent bonding. Okay, so that is out of the way. I'll go to my PowerPoint. Okay, let me know you guys nampak ke tak? You guys nampak my PowerPoint?
Nampak.
Okay, good. Just trying to make sure I'm presenting the right thing. Okay, so today, the first part kita akan belajar pasal polarity and dipole moment of basic molecular shape. So kalau you guys ingat hari tu kita ada belajar kan, all cara nak lukis semua, all those basic kan. Kita tak belajar yang today, kita hanya tengok shapes yang tak ada lone pairs. Hari tu kita belajar sampai lone pairs lah, jadi bentuk V shape lah semua tu kan. Hari ni kita only tengok on the basic shape. Basic shape tu macam linear, trigonal planar, tetrahedral, trigonal bipyramidal and octahedral. Only those 5 je yang kita akan tengok, and kita akan explain its polarity. And then kita akan tengok intermolecular forces on van der Waals forces, dipole-dipole and London forces. Hydrogen bonding tu kalau ada masa kita akan pergi. So pretty much kita akan belajar dipole-dipole and London forces. This is apa yang contoh saya tunjuk tadi lah. Basically kalau saya tarik my model tu, the velcro akan dicabut dulu, benang tu tak tercabut lagi. So kita akan belajar those forces. This is one of the fundamental forces. Kalau you guys pun belajar physics kan, you got the strong forces, you got the nuclear, you got the weak forces. So kita akan start my slide. Okay, the first thing is kita akan tengok pasal polar and non-polar molecules. Yang hari tu, you guys nak kena determine pening apa tu polar, apa tu non-polar tu dalam assignment tu kan. So this is basically what define polarity. Kita tengok by dipole moments. Okay, so don't worry, this semester you guys tak perlu kira, but semester 3 probably akan ada. So you guys have to know je lah kalau dia orang cakap pasal dipole moment tu datang dari mana. So I think physics pun nanti pasal electricity pun nanti you guys akan belajar pasal charge semua tu. Dah masuk ke? Tak kot. Maybe sem kedua kot. Belum yet. So dipole moment, kita define it as the product of charge, which is Q, and then darab distance between the charges. So contohnya between hydrogen, which is plus, dengan fluorine minus, and then kita darab the distance between hydrogen and fluorine, and kita tulis dia the express in debye unit. Dia akan tulis D besar. Tu je. So kalau dia cakap maybe comparing between 3.77 debye and 2.0 debye, maksudnya satu tu lagi more polar lah than other. Okay, the higher the debye unit, the higher the polarity lah. Okay, now kita akan tengok this is the factors that kita akan discuss lah. So factors affecting polarity, we have two things. Okay, we have electronegativity and molecular geometry. Let's look on electronegativity first. Okay, electronegativity, kalau you guys tengok you punya periodic table kan, periodic table. So, and then you have this, and this, and this. Okay, chapter 652. Across the group, apa jadi dengan electronegativity?
Meningkat.
Yes, meningkat. And kalau down a group, electronegativity pun rendah. And one thing to note is fluorine is the highest electronegativity. Selalunya kita akan just tulis dia as 4. 4 is the highest electronegativity punya values lah. Tapi some also the actual value is around 3.98 macam tu lah. Tapi kita nak senang kita cakap 4 je. So, factors affecting polarity. Apa yang kita tengok is the first thing is electronegativity. Okay, kita tengok most of the time is the difference in electronegativity. Okay, jika bond with the same atom between two electropositive atom. So, what if wah, belum pusing lah. So, kalau between H, F and F. So, kalau you guys nak tengok which one of these are polar, okay. Kalau you guys rasa HF ke FF yang polar?
HF.
Yes, kenapa? Kenapa ini tak polar?
Sebab dia ada dia predictable.
Okay, macam hari tu saya cakap, lagi jauh dia duduk, lagi the higher the difference in electronegativity, lagi polar dia lah. So, kalau HF, nilai H is around 2.2 and F around 4. While this 1F is 4, this is also the same fluorine then. So, the difference will be kosong. So, it will not be a polar molecule. So, that hence kita akan dapat non-polar. So, any je molekul yang you jumpa, H2, O2, F2, ataupun chlorine gas. Okay, kalau dia ada the keyword gas, you guys boleh tulis dalam you guys punya buku. Gas, kalau dia cakap elemen, dia cakap apa-apa elemen, gas. Contohnya chlorine gas, bromine gas, iodine gas. The formula will always be, apa dia punya formula tu? Ada 2. So, hence they are the same element, which is kalau ini is iodine ke iodine, the electronegativity difference will be 0. So, it will not be a polar molecule, it will be non-polar. Okay. Ataupun, tengok between, dia cakap between two electropositive atom, C and H. Boleh tengok, carbon, okay, carbon and hydrogen. So, carbon is 2.55, while hydrogen is 2.2. Okay, beza dia orang around 0.35 je macam tu. So, even though ada difference, they also counted as non-polar because the difference is very small, is negligible. So, bila kita nak tahu the difference is banyak and kita akan consider dia polar. Okay, it should be around 1.7 till 2. Ataupun maybe higher lah, higher than 2 pun okay. So, around 1.7, around 1.5 pun kita dah consider it as polar. Okay, boleh. Kalau setakat 0.3 tak sampai 1 pun electronegativity difference, kita consider it as non-polar. Jangan risau mana saya dapat nombor-nombor ni akan diberi dalam exam. You guys tak perlu nak hafal electronegativity. Just on a quick note, one thing is good to know is dalam banyak-banyak elemen yang dalam periodic table tu, fluorine is always the highest, the most electronegative element. Fluorine. Okay. And then, kita tengok, kalau electropositive and electronegative atom, dia akan jadi polar. Macam saya tunjuk tadi, HF. Beza dia banyak kan? Beza dia around 1.8 and HCF. So, kalau you tengok, kalau lah elemen tu, okay, molecule tu is from one of the element is from group 1 or 2, and then digabungkan dengan apa-apa yang dekat belah group 17, which is this one, is most likely dia orang akan jadi polar. Nampak tak jarak dia orang very jauh. Okay, kalau you cakap yang tu, tengoklah kenapa CH tadi tak, walaupun jarak dia orang jauh tapi dia orang tak polar kan. CH C dekat P block, while H dekat S block. Okay. This is all come down to electronegativity. Okay, you always kena compare is electronegativity. Okay, boleh? And now kita tengok on molecular geometry. Okay, molecular geometry is also boleh affect dia punya polarity, even though it is contohnya lah kalau bond tu is carbon and chlorine, polar ke tak?
Carbon and chlorine.
Yeah. So I'll give carbon is 2.55 while chlorine is 3.16. Okay, so one thing to take note is kalau group 17 je is most likely polar. Apa-apa je dengan group 17 is most likely polar unless dia dengan diri dia sendiri. So I would say this is a polar bond. Okay, dia polar. Tapi what if kalau it is CCl4? CCl4, kalau saya buat Lewis structure, saya buat dia punya molecular shape, I'll get tetrahedral. Cl, and then Cl. Even though the individual bond are polar, tapi bila dia dalam symmetrical shape, dia dah jadi non-polar sebab dia cancel each other. Okay, contoh non-symmetrical ni dalam assignment you pun dah ada hari tu. The only polar molecule CH2Cl2. See? Okay, apa maksud dengan symmetrical and non-symmetrical? Okay, symmetrical tu is the basic shape and only if kalau semua terminal atom dia is the same. Okay, sebab kalau you tengok, you pusing macam mana pun, it will still have the same kan. Kalau you ambil ini letak sini pun, it will still be the same molecule kan. Betul tak? Tapi kalau ini, you pusing dia already have become different molecule. This one dengan duduk this one ke. Okay, so it is not symmetrical. So it will be polar. Okay. So factors affecting polarity is very easy. There's two things you have to consider. The first, you have to consider the bond polar ke tak. Okay. Then kalau dia polar, kalau dia tak polar, dia terus non-polar. It's very easy. Tapi kalau dia polar, you have to do the second step. Tengok dia punya molecular geometry. Symmetrical atau non-symmetrical ke tak. Okay. Symmetrical ni, apa maksud symmetrical? Maksudnya if you draw a line, any line, one that is on this side of the excuse me, ini punya side of the line and the other side punya line, they have the same molecule. Kalau you pusing macam mana pun, they will be the same. Kalau I draw this line, this molecule rotating this way, they will be the same. Okay, non-symmetrical, kalau I so if I draw a line here and I rotate this molecule, it already dah become the different molecule. Okay, so now Everyone faham tak how polarity, what factors affecting polarity? So first, electronegativity, kita tengok from the value, dia polar ke tak, and then kita tengok from molecular geometry. Okay. Next, kita tengok contoh HF. Okay. HF, for example, hydrogen is covalently bonded with fluorine. So kalau you tengok nilai H is 2.2, while fluorine is 4. Kan? Betul tak? So, kalau tengok the electronegativity difference is quite high. Okay. Kita tulis sebab pun tak apa. So, fluorine that have the tendency to put a bonding electron to itself. Okay. Cara kita nak represent dipole moment, because nanti you guys nak tentukan, you guys kena lukis. So cara nak tentukan dipole moment, you tengok which atom is the more electropositive atom. So hydrogen ke fluorine? Electropositive. Yes. So hydrogen. So what you will do is put a plus, okay? Put a plus, tapi jangan berhenti, sambung je, tunjuk arrow. Okay, arrow ni maksudnya dekat mana plus dia tu is the more electropositive atom, and this arrow represent the distribution of the electrons. So because what happened is H and F, okay, they are sharing electron kan, covalent bonding kan, and then since fluorine is more electronegative, so they have the tendency of pulling more electron dekat dia lagi tamak. So what happen, dia orang punya share electron will be like this. Okay, lagi banyak the electron yang share tu duduk dekat fluorine. Fluorine lebih suka ambil. Hydrogen ni tak apa, dia pemurah. So, that's why kalau ini, dia akan represent by partial positive charge. So, at this moment, kita akan represent the H as positive and fluorine as negative. This, kenapa kita tak tulis ini and kita tak tulis macam ni? Kenapa kita tak tulis H is plus while fluorine is minus? Okay. This is, okay. Dalam buku korang, kau boleh highlight partial. Kenapa partial? Because remember, we're talking about covalent bond. Covalent bond can only have sampai partial. If the full plus or minus, dia already dah jadi ionic bonding. Okay. Kalau ionic high tu, kita tengok the difference is quite high kan, the electronegativity. I think 2. So now, if it's bonded, is covalently bonded, so hydrogens have the partial positive charge and fluorine have the partial negative charge. Hence why kita dalam exam kita takkan nak setiap kali nak lukis H, lepas tu kita lukis ini semua. So, kita represent it only by using an arrow. Buat plus dekat the more electropositive atom, dan tarik arrow tunjukkan direction of the electron. So, more electron will be at fluorine. Okay. That's why kita juga cross arrow. Okay. Boleh? Ada orang mau masuk. Okay. Nampak kan my PowerPoint?
Nampak.
Okay. Now, kita tengok pula CH4 methane ni. Okay, kalau kita tengok carbon and hydrogen, the electronegativity difference yang saya tunjuk tadi, the electronegativity difference is around 0.3. Okay, 35. Okay, the electronegativity difference is negligible, is very small. So, kita tengok this bond pun dah non-polar. So, this bond pun dah non-polar. Kalau you tahu, kalau you tengok between the first, between C and H pun dah tahu is non-polar. So, the whole molecule is non-polar. That's it. The only way bila you tengok is between the central atom and the terminal atom, or dia ada huge electronegativity difference. So, it is a polar bond. And then baru you tengok dia punya molecular geometry. Okay, HF ni linear. Okay, dia linear. Tapi dia symmetrical ke tak? If I do a line, okay, I do a line here. Symmetrical or not? Belah kiri sama tak dengan belah kanan? Tak kan? So, it is not symmetrical. So hence, that's why HF is a polar molecule. Okay, so yeah, this one is polar molecule. Okay, boleh. So, okay. So, kita basically akan tengok two things. Diatomic, which is ada dua atom, and kita tengok containing atoms of different element. Different element maksudnya dia takkan jadi symmetrical. So HCl, tengok this one, nitrogen, oxygen, then carbon monoxide. Okay. While this macam hydrogen gas, nitrogen gas, ataupun chlorine gas. Okay. Kalau je dua atom tu have different element, the first thing you have to tengok is diorang ada tak dipole moment. Ada tak untuk dapat macam ni? Boleh tak dapat macam ni? Okay. Kalau diorang ada, kita tengok it means it is a polar molecule. Look at like this. Chlorine is a electronegative element. Dia around 3.16. Tapi kalau you tengok both are the same chlorine. So electronegativity difference tak ada pun antara diorang ni yang lagi baik. So kita ibaratkan plus ni kita nak tandakan orang yang baik, and then tunjuk arah elektron yang dia derma. Kalau diorang sama-sama tarik elektron tu, so tak ada which one of this is lebih baik. So both of the atoms tarik the same amount of electron. So we have no dipole moment. Hence, kalau diatomic molecule, kalau dia sama je atom, it will be non-polar molecule. Boleh? Okay. Kalau je atom tu lain, HCl, NO semua tu, and then baru you tengok dia punya electronegativity difference tu jauh ke dekat. Okay. Kalau carbon and oxygen, carbon is 2.55 and oxygen is 3.44. The difference kalau you tengok is almost 1 kan? Almost 1. So, do you think it will be polar?
No.
It's actually polar. Okay. Because as long as kalau dia around nak dekat 1, more than 1 sikit, kita can consider polar lah. Okay. Most of the time, there's a few elements that you guys can spot nak tahu dia polar ke tak. Okay, group 17, kalau dia ada group 17, is most likely polar. Dia ada oxygen, sulfur maybe. Okay, ataupun nitrogen. Nitrogen, oxygen, and group 17. So, write this down, nitrogen, oxygen, and group 17. Any atom yang non-polar, not electropositive, gabung dengan this kind of elements will be most likely polar. Okay, since CO is polar, macam mana I nak draw the arrow, cross arrow, positif ke kat mana? Kat carbon kan? Yes. Okay. So, arrow dia ke arah oksigen. Okay, boleh? Now, kita akan tengok polyatomic atom. Tadi kita tengok just only 2 atom. Okay, sekarang kita tengok kalau dia ada banyak, more than 2. Okay, contohnya carbon dioxide. Okay, macam lepas kita buat Lewis structure, kita dapat dia punya molecular geometry and kita dapat it is a linear. Okay, kalau kita tengok, and saya cakap tadi oxygen and carbon, so oxygen is more electronegative than carbon. So, macam mana saya nak draw dia punya dia punya dipole moment punya arrow tu? The positive should be dekat mana? Yes, still sama macam kalau dia only 2. So, same. And we also have here kan, kiri and kanan. So, if you look, dipole moment of this can cancel each other. Satu pergi kiri, satu pergi kanan. So, the dipole moment cancel each other. So, we have no net dipole moment. Because dipole moment ni, okay, fizik dah belajar kan, is vector. Is vector quantity. So, vector dia ada direction and dia ada magnitude. So the important thing is dia punya direction. So if, because this are both carbon to oxygen kan, this carbon to oxygen, this one pun carbon oxygen, we can assume that they have the same magnitude. Since same magnitude, tapi opposite direction. So, same magnitude and opposite direction, it means it will cancel each other. So, contohlah, dia ke kiri is negative 2. Because ingat kan, vector kita kena letak charge kan, dia punya positive or negative. Kita just denote dia as negative or positive untuk tentukan dia punya arah. And contohnya ke kanan positif. It will cancel out and become, it will become 0, kan? So, even though it is start with polar bonds, tapi kita ada the other side, kita become a non-polar molecule. Sebab the dipole moment cancel each other. Okay, boleh? Let's see this, the second molecule, carbon tetrachloride. Okay, you tengok carbon, tengok chlorine, polar ke tak? Ada dipole moment tak? Sebab chlorine ni macam saya cakap tadi is group 17 and NO dengan group 17 tu usually kalau kita gabung dengan apa-apa, it usually will be polar lah, because dia orang is quite electronegative. So, macam saya nak draw the arrow. Arrow tu positif belah chlorine ke belah carbon?
saja.
Yes. The more electropositive, kita letak positif. So, untuk dia punya molecular geometry, we also draw the arrow on every single bond. Okay. So, even though it doesn't look like they cancel each other, hari tu saya ada tunjuk my model kan. Mana my model? Okay. I'll show you my model. Okay, I'll show you my model. Okay, look. If every of the dipole moments are pointing away from the center atom, actually look, this, even though you tak nampak macam symmetrical, is actually symmetrical. One dipole moment is going this way, one is down, the other is here pointing to me, and the other is pointing to you. And it cancel each other. So, the general rule is, kalau it is a basic shape, itu kita belajar pasal linear, trigonal planar, tetrahedral, trigonal bipyramidal, semua tu, it will be non-polar only if you punya terminal atom semua sama. Okay. Because you guys ingat kan, hari tu you guys buat assignment, ada dichloromethane. Even though dia is tetrahedral, tapi dia dua H and dua chlorine. Carbon ke hydrogen is non-polar. Dia tak ada dipole moment. Tapi carbon ke chlorine ada. So, ada dua je chlorine tu. Okay, bayangkan these two is hydrogen and these two is chlorine. So, these two chlorine cannot cancel each other. Dia orang tak ada counterparts dia orang yang nak cancel dia orang. Carbon and hydrogen is non-polar. So, that's why dichloromethane itu is a polar molecule. Boleh?
Yeah.
Okay, nampak balik my PowerPoint?
Nampak.
Okay. So, carbon tetrachloride is non-polar. And we look on chloromethane. So, what happened? Now chloromethane, diorang kalau kita dah buat molecular geometry, we will also have got tetrahedral. Tapi look, carbon and hydrogen, macam saya point out tadi, this is have no dipole moment. Tapi carbon and chlorine has dipole moment. Okay, so carbon dipole moment ni ke arah chlorine when carbon is more electropositive. So look, so ada tak yang nak cancel this dipole moment? Tak ada kan? This one dah tak ada, ini pun tak ada dipole moment. This one also tak ada dipole moment. So tak ada nak cancel this. Hence, kita CH3Cl2 is a polar molecule. Okay. So, kita tengok pula ammonia. Okay, ammonia is also tetrahedral with a lone pair. Tapi kalau you tengok the shape molecular geometry dia, the shape is trigonal pyramidal. Okay. Now, hydrogen and nitrogen, kalau you tengok, the difference is around 1 point something. Okay. So, it is, kita can consider this as polar. So, we have this, we have this, and we have this. Okay, lone pair, kita consider them as not, tak wujud pun, tak ada electronegativity. So if you guys can see, dia macam ibarat all those arrows are pointing there. So we have a net dipole moment of ke atas. So that's why ammonia NH3 is a polar molecule. Okay, boleh?
Boleh.
So basically what you guys kena tengok macam tadi, the first step is electronegativity. Kita tengok the bond itself is electronegative, ada huge difference in electronegativity ke tak, and then baru kita tengok molecular shape. Okay, from the molecular shape tu yang kita kena figure out whether dia symmetrical ke tak. Okay, tadi aku juga dah tulis, tapi if kalau all same terminal atom, kalau semua terminal atom dia sama and it is a basic shape. Okay, basic shape, can you list me down the basic shape? Shape yang tak ada langsung lompat.
Kat linear.
So kita ada linear, and then trigonal planar, lepas tu tetrahedral, trigonal bipyramidal, and last one is octahedral kan? Okay, good. Okay, if kalau all of the terminal atoms are the same and the molecular geometry is one of this, so tak ada distortion langsung, it is terus will become non-polar. Okay, kalau ada question tanya kenapa it is non-polar, because the net dipole moment is 0. They cancel each other. Okay. So now siapa sini yang ramai tak yang guna phone? Oh, you guys guna laptop. Okay, phone pun tak apalah. So I want you guys to masuk this quiz. It's only have 4 questions and we can go through it together. So I want to okay, dekat here I'll give you the link. Siapa yang dekat laptop, can you share it dekat WhatsApp kita tu? Because saya tak ada buka WhatsApp sekarang. Kita masuk this, and siapa yang tu just masuk je and let me know boleh masuk ke tak. We have a quiz on yeah. Kita ada quiz pasal dipole moment and polarity sahaja.
Masuk je.
Masuk. Don't worry, dia tak start lagi. Hebat betul nama durian dah botol. So, anyone yang ada trouble nak masuk? Just masuk.
Sekarang tu.
We'll do the quiz and then we'll take like around 10-minute breaks. And we will go through this together.
Oh, okay.
Don't worry. Mana lagi 6 orang lagi. The others, do you have trouble masuk or everything okay? If so, let me know kalau ada trouble masuk. At 8:50 kita akan start. Apalah the others. You guys can still try this quiz nanti. Cepat sikit siapa yang tak masuk lagi tu. Okay, I'll start the quiz, okay? And we'll go through together. Okay, define dipole moment. Okay, dipole moment tadi is Q darab R kan?
Yeah.
So, which one of it is dipole moment?
Sampai itu.
Okay, tak apa, nanti kita can try again later. Now, next question. So, kalau HF, positive charge dia belah mana? Siapa yang the more electropositive? The faster you jawab, the higher your marker, I think. Okay, hebat durian ni. So, and then we go on to the third question. Don't worry, you already did half. Okay, mana molekul ni is polar? So remember, kita tengok the electronegativity and then kita tengok molecular shape. Dia symmetrical ke tak? So you have to pilih dua. Which one is? Pilih dua. Kalau dia symmetrical, even though dia polar, it will not be. The molecule will be non-polar. Okay, now let's look at the last question. Okay, between these two, yang mana satu polar? Okay, good. So, who got the first place? Oh, good job, Iza. Durian Dumbledore, the last one you got beaten lah. Siapa tu Durian Dumbledore?
Saya.
Okay, tak apa. So, we'll take a 10-minute break. 3 minutes, kita akan start balik. And kita akan tengok balik which one that most of you got it wrong. Which is the dipole, the polarity. How it is defined. Okay. Okay, now you guys can have your 10-minute breaks. Okay, so tadi I think a lot of you struggle with the definition of dipole moment lah, because we determine everything, kita determine all of polarity based on dipole moment. So kita tengok balik this and then here. So nampak that polar and non-polar molecule. Okay, dipole moment where kita denote is dia macam U tapi ada kaki panjang, macam kepala cockroaches. Okay, so and it is QR10. Okay, Q ni is charge atom, okay, while R is a distance between them. Okay, kalau dia orang tanya pasal definition, sekejap, you guys nampak kan my slide? Nampak?
Nampak saya.
Okay, so kalau benda yang ada formula sama macam physics, disuruh minta definition, what you have to do is write the formula, U ada kaki, and then QR, and then you just terus define apa tu Q, apa tu R, terus dapat full mark. So Q is the charge of the atom and R is the distance between the charge. Okay, boleh? So basically apa yang dipole moment ni, contoh macam H and F, and kita tahu hydrogen is more electropositive kan? So denote it as partial electropositive and partial electronegative. Okay, so basically apa dipole moment tu, kenapa kita dapat the arrow like that is kita kira the product of positive charge and the negative charge and the distance between them, because we know that hydrogen punya atom also be close to fluorine. So dipole moment yang kita kira is the difference between the charge and then the distance between the charge. Okay, boleh tak? Faham tak? Kenapa kita dapat HF? So jangan risau, dalam exam untuk 7.3 most of the molecule they will give you will be basic shape. Okay, so only one thing yang you guys kena take note is tengok terminal atom dia sama ke tak. Okay, let's do one contoh. I'll add ni sekejap . Okay, let's do one contoh. Molekul ni awak dah pernah buat. Mau buat apa? Yes, PF5. Awak pernah buat, awak ingat tak dia dapat bentuk dia apa?
Diagonal bipolarizer.
Yes, very good. Wah, saya ingat saya punya bond. Tak apalah, bayangkanlah bond tu tak saya ingat. Okay, so kita dapat here and here. Okay, macam mana nak denote dia punya dipole moment? Okay, you tengok phosphorus and then you tengok fluorine. So I'll give that phosphorus is 2.19 while fluorine is 4. Okay, as you can see, the electronegativity difference is quite high kan? It's around 1.81 macam tu lah. So you guys rasa the P and F bond ni polar ke tak?
Monopolar.
Dia orang polar kan? So, okay. Ini bukan the total one. Saya tak tanya pasal the molecule. Saya tanya P dengan F saja. Dia polar ke tak?
Oh, polar.
Yes. Sebab
Polar.
electronegativity difference dia around apa tadi saya cakap tu lah. Around 1 point something kan? Macam tu kot maksudnya. So, kalau you tengok, which one of the between P and F is the more electropositive?
P.
Yes. So, kalau you tengok, P is more electropositive. So, cara kita nak denote is like that kan? All the electron will go to F. So, it is a polar bond. Tapi that's only for P and F. Now, we have a molecule of PF5. So, kita dah tahu it is kita dah tengok electronegativity. Kita dah tahu each of this bond is polar. Tapi, when they are in a molecule, diorang punya dipole moment, okay, cara nak denote dipole moment, you have to memang perlu buat untuk semua. Untuk semua dia punya bond, semua awak kena buat. So if you guys can see, this one, the bottom one will cancel with the top one. While these three akan cancel each other. It will result in no net dipole moment. Which is dia punya dipole moment is U ada kaki will be 0. So hence kita akan dapat a non-polar molecule. Even though dia ada polar bond. Okay. Boleh tak? Kalau tak faham? Okay, kita buat lagi satu contoh. This slide. Okay, now kita always have the two steps. First, kita tengok electronegativity. And then second, kita tengok molecular shape. Okay, tadi punya kita tengok electronegativity dia, the difference is quite high. So kita tahu each of the bond is polar bond. And then baru kita tengok dia punya molecular shape. Molecular shape, it is a basic shape. Kalau je shape tu is apa-apa je yang basic shape, it will have no net dipole moment. Only given yang saya cakap tadi, the terminal atom must be the same. It's trigonal bipyramidal. Okay. Now contohnya is this CH and then Cl3. Okay, kalau you buat you buat you punya molecular shape, you akan dapatlah hydrogen, chlorine, and then chlorine. So if you guys can see, kita nak buat the first step. So the first step, kita nak check electronegativity. Kita ada dua atom, kita tengok, kita ada carbon and chlorine and also carbon and hydrogen, kan? So kita tengok carbon and hydrogen dulu. So carbon is given 2.55 and hydrogen is 2.20. The difference is only 0.3 something, 35. Okay, so it is non-polar. Kan, this bond C dengan H is non-polar. Tapi now kita tengok untuk C dengan Cl. Okay, carbon is 2.55 and then kalau chlorine is 3.16. Kalau you tengok merge my calculator, 3.16 minus 2.55, kita dapat 0.61. Okay, plus one more thing, that chlorine is a group 17. So macam saya cakap tadi, kalau ada group 17, ada nitrogen, ada oxygen, those are very electronegative atoms. And also group 17 are quite electronegative. Almost dengan apa-apa yang lain, they will form a polar bond. So since the value is quite high, it counted as polar bond. So kita dah tahu C dengan Cl is polar. So which one is more electropositive, carbon ke chlorine? Ada tak sini? Carbon kan? So our tanda the dipole moment, lukis arrow for dipole moment, start positive from carbon ke arah chlorine. Okay, so as you guys can see, dia punya net dipole moment is ke bawah, kan? Sebab carbon ke hydrogen tak ada kan, so dia orang non-polar. So they have, even though it is a basic shape, kan, tetrahedral kan, tapi you tengok it is not symmetrical sebab kita have one hydrogen, bukannya semua terminal atom is chlorine. Non-symmetrical. So we will have a polar molecule. Even though they have satu polar bond, satu non-polar bond and 3 polar bond, it will result in polar molecule sebab dia punya molecular shape is non-symmetrical. So the first one, kita check every single bond, mana satu polar, mana satu non-polar. And then second step is kita tengok dia punya molecular shape, which is now even though it is tetrahedral, kalau kita letak hydrogen ni boleh letak mana-mana kan, letak mana-mana pun it will still result in a non-symmetrical molecule. It has a net dipole moment dekat bawah, thus resulting in a polar molecule. Everyone okay with that? Or nak buat lagi satu contoh?
Dia aja.
Buat tu.
Okay, so kita buat lagi. Okay, what if, okay, soalan tu just bagi CO2 and then dia cakap determine its polarity. Okay, soalan begini je. So, let's do every single step macam ibarat you dalam exam. Kena buat sendiri. Dia orang tak bagi molekul tu. So, cara macam mana you nak dapatkan molecular geometry semua tu? Macam mana? Macam mana awak nak tahu dia punya molecular structure? What's the first step you guys have to do? Yes, kira valence electron sebab you nak kena buat Lewis structure kan? Can you kira the total valence electron for this? So carbon is group 4 kan? Group 14. So 4. Oxygen is group 16. So ada 2. 12 tambah 4. 16 kan? So it is 16 electron. And then between carbon and oxygen, which one is the more electropositive atom? Carbon. And then kita letak je oxygen keliling dia. And then kita nak completekan octet for terminal atom. Kita buat 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So kita kena 12 untuk completekan octet. And kita ada 2 bond. So 1, 2, 3, 4. 12 tambah 4, which is dah already 16. Tapi carbon is still not octet. The only benda yang kita tak boleh buat double bond is hydrogen and group 17. Oxygen group berapa? 16 kan? 16. So dia boleh buat double bond. So what I'll do is I ambil one of the lone pair, jadikan double bond. So it will come okay. Tapi you guys tengok
double bond.
yes. Sebab kita tengok carbon is still not octet kan? Macam kawan kita cakap tadi, dua-dua belah kita buat double bond. So, okay. Okay. You guys check. Kalau dah habis Lewis structure, always check semua ni octet ke tak? Oxygen octet, dua-dua ni. Ada 4, 5, 6, 7, 8. Kan? Carbon pun dah octet. So, okay. You ada Lewis structure. Then you can figure out dia punya molecular geometry. So, nak tahu molecular geometry, you have to look electron pairs. Hari tu saya cakap, even though dia ada double ke triple bond, kita consider this as one pair. Sebab kita basically just nak tengok how many bonded terminal atom yang ada dekat central atom tu. So, kita lukis balik C and it will get 4 and 4. So, it will have linear shape. Sebab dia ada 2 kan? Dia ada 2 pair. Even though dia ada 4 bonding pair, kita only consider berapa banyak. Kita only consider sigma bond. Sebab this one dia ada sigma and pi. Sigma and pi. So kita only consider sigma bond. So dia ada 2 pair. So now kita nak determine dia punya polarity. So carbon and oxygen. Okay. Tadi carbon is 2.55. Don't worry, once again the value will be given. Oxygen is 3.44. Okay, kira dia punya electronegativity difference. Is it more than 0.4? .44 minus 2.55, 0.89 kan? Alright. So it will be polar. Plus oxygen is one of the thing yang saya cakap tu is very electronegative. Nitrogen, oxygen, 270. This is a very electronegative. Okay, tulis penuh lah. Kita tulis electronegative elements. So it means that carbon and oxygen will have a net dipole moment. And we know carbon is more electropositive kan. So, you nak determine ni, carbon dioxide ni polar ke non-polar molecule. So, you draw dia punya dipole moment. So, I draw the dipole moment. Allah, sama kali. Tak apalah. Okay. They are bonded to the same atom kan. Satu carbon ke oxygen, lagi satu pun carbon ke oxygen. And you know dipole moment is mu is equal to charge times dia punya radius. If dia orang bonded to the same atom, will be the charge dia akan jadi sama ke berbeza?
Sama.
So same kan? So the magnitude will be the same. The only difference is satu ke kiri, satu ke kanan. So if kalau charge is the same, contohlah I will give the charge, you takkanlah soalan takkan keluar untuk kira charge, contohlah, tapi dia bagilah. So dipole moment ke kiri is negatif 2, while negatif 3 lah, negatif 3, while pergi ke kanan is positif 3. So dia ada net dipole moment tak? The dipole moment, the net dipole moment will equal to 0. Sebab kalau you ingat, dipole moment ni, the reason kita buat arrow sebab dia ada direction. Okay, arah play a major role in dipole moment sebab it is a vector quantity. That's why kalau you tengok, the formula is mu equal to the dot product of the charge and then times the radius. You guys belajar physics and you know dot product most likely dia orang can be vector kan. So the final result that carbon dioxide is a non-polar molecule because it has no net dipole moment. Okay, boleh?
Yes.
You guys okay ke, or you guys nak buat one more, kita buat lagi satu lah. Okay. New slide. Okay, how about aluminium Br2? Okay, berapa total valence electron dia? Can you guys kira for me? Aluminium is group berapa? Group 13 kan? Yes, it has 3 valence electron. And then bromine, kita ada
17, right?
group 17 and kita ada 7. So the total valence electron is
24.
24. Okay. And then, so kita tengok, kita buat dia punya Lewis structure. Aluminium is the more electropositive. Okay, I'll give the electropositive punya values, okay. 1.61. Bromine is 2.96. Okay. So aluminium is the more electropositive. Kita letak tengah. So kita letaklah bromine kat keliling dia. Bromine, bromine and bromine. And we will try to complete the octet. So this one is 6, 12, 18, 18, and then kita ada 1, 2, 3, 4, 5, 6 as bonding. So 18 tambah 6 we will get 24 kan. So kita dah use all of the valence electron, betul tak?
Yeah.
Tapi aluminium is still not octet. Can we do anything? What were the element yang tak boleh buat double bond? Yes, hydrogen. Group 17. Bromine group berapa? Tengok periodic table. Bromine is group 17. So kita dah tak boleh buat double bond. So this is the final Lewis structure. So it is, kalau you guys ingat itu, this is incomplete octet. Kan? So kita nak buat molecular geometry, kita always only look at the central atom. So kita tengok central atom ada berapa pair, ada berapa sigma bond. Ada berapa? So kita ada elektron pair, kita ada 3. Kalau 3 shape dia apa? Ingat tak?
T-shape, trigonal planar.
Trigonal planar. Basic shape. From the electron pair, kita always got basic shape. All those shape yang kita cakap T-shape, seesaw, band, semua after kita consider lone pair, where the central atom tak ada lone pair kan. So kita dapat trigonal planar. So kita pun lukislah trigonal planar aluminium, and then lukis bentuk Y, and then complete. Untuk molecular geometry kita tak perlu tulis lone pair. The only lone pair yang penting is dekat central atom, in which aluminium ni tak ada central atom punya lone pair kan. Okay, kita dah buat dia punya molecular geometry. Let's determine aluminium and bromine. Bond ni polar ke tak? So you tengok from the values, 2.96 minus 1.61. What's the value? Apa electronegativity difference dia? Berapa? This is the electronegativity value for bromine. This one is electronegativity value for aluminium. Kalau you tolak, dia dapat berapa?
1.35.
1.35. So it means that it is polar kan? It is more than 0.4. So it will be polar. So between these two, mana satu yang the more electropositive? Aluminium. So the dipole moment, kita start dengan aluminium, kita buat tambah, and kita arrow ends dekat bromine. Sebab bromine is more electronegative, dia akan tarik elektron. So dekat you punya molecular geometry, lukislah semua tu. Okay. So positif dekat aluminium, Semua elektron dekat aluminium ni ditarik ke bumi. So, if you guys can see, even though the bond is polar, it's a polar bond, we will get a non-polar molecule because it is basic shape and it is symmetrical. Thus, it has no net dipole moment. Okay. Kalau even though you tengok macam mana dia nak kira ni. Korang dah belajar nak kira vektor ke belum dalam physics?
Dah.
Dah belajar, ingat tak kalau ada angle tu you kena kira angle and then letak cos ke sin ke semua tu kan?
Okay.
And then you kena buat 2 kolom kan? Ya, kena buat 2 kolom. Okay. Same thing. Kalau awak kira semua ni based on the angle, kita ada 120 degree. Kalau awak kira the total dipole moment will get 0. Okay, but since this is chemistry, you tak perlulah kira banyak-banyak. Nanti fizik kena kira, ni kena kira, mati korang. Kan? So, apa yang nak ingat, as long as it is basic shape and semua terminal atom sama, it will have no net dipole moment. Basic shape, you ingat kan? All the initial 5 tu yang kita belajar linear, trigonoplanar, and then kita ada tetrahedral, and then kita ada trigonal, bipyramidal, and octahedral. But that's only when symmetrical. So symmetrical bila all of the terminal atom is the same. Okay. Boleh? So don't worry about this cos apa semua tu, you takkan diminta untuk kira. So apa yang you perlu decide is you kena buat molecular geometry and then you kena figure out whether it is basic shape and then you tengok dia punya terminal atom semua sama ke tak, and then you tengok the bond itself, is the bond polar ke tak. Kalau macam tadi kita tengok pasal C and H bond, the difference is very small, it's around 0.35. So we can, kalau you tengok bond, tak ada bond langsung yang polar pun, so the whole molecule will be non-polar. Sebab the bond pun dah tak polar, macam mana nak dapat polar? The only polar molecule will get kalau the bond itself is polar and then it is not symmetrical, so dia tak boleh cancel the dipole moment. We will get polar. Very rarely for now, kalau kita tak consider lone pair, kalau basic shape, most of the basic shape will get non-polar. Unless macam dia punya assignment dari chloromethane tu. Sebab dia non-symmetrical, dia ada hydrogen and ada chlorine. So everyone okay? Okay, good. Do you have any question? Ada soalan tak? Okay. So far so good. I'll introduce about intermolecular forces sedikit. Okay. I'll go through intermolecular forces. Okay, nampak kan my slide?
Nampak.
Okay, good. So, kita only have 2 intermolecular forces. Ibarat yang saya tunjuk dekat kamera saya tu, kalau siapa tengah tengok kamera saya ni, it's just the velcro tu. Kita belajar pasal velcro tu. Okay, kita tengok mana satu velcro yang paling kuat, mana satu yang paling susah nak tarik. Okay, so kita akan belajar dua forces, van der Waals forces and hydrogen bonding. Okay, for me hydrogen bonding is the most interesting because it basically enables life on planet Earth lah. Tapi I don't think kita sempat sampai hydrogen bonding. Kita akan belajar van der Waals forces for today. Van der Waals ni kita ada dua, London and dipole forces. Okay, saya tulis dua-dua sebab sometimes buku tulis dua-dua, but most of the time kita akan identify as London forces and dipole forces. Okay, boleh. So this is the general strength of the intermolecular forces. Hydrogen bonding is the strongest out of all intermolecular forces, followed by dipole, and London is the weakest. Okay, tapi kalau you tengok, look at my camera. Okay, doesn't matter lah. All of this velcro ni London forces ke, dipole ke, hydrogen bonding ke, those, even though kalau saya cakap tadi hydrogen bonding is the strongest, it will never be stronger than intramolecular forces macam covalent or ionic. Dan kita tahu covalent or ionic is way stronger than intermolecular forces. So if the one I give energy, the first one to break is the intermolecular forces. So kita nak tengok which of the intermolecular forces is the weakest, strongest. Okay, and kita tahu hydrogen bonding is the strongest. Kita tengok what effects does those forces have. Okay, so kita tengok van der Waals forces dulu. Cara nak tulis, make sure tulis betul tak? Van, macam van yang awak naik tu, der, and then Waals ni dia ada double A tau, jangan letak double L. Double L tu dinding ataupun ice cream tu, kita tak nak. Kita tengah cerita pasal forces. Is van der Waals, W-A-A-L-S. So let's see the two type of the van der Waals forces. Okay, the first one is dipole forces. Okay, buku korang, buku nota, can you guys tengok ada tulis tak van der Waals forces, dipole interaction, muka surat 75. I need you guys to highlight it is permanent positive and negative end of polar molecules. Okay, highlight polar molecules because dipole forces only exist in polar molecule only on polar molecule. Molekul yang tak polar tak ada will not have dipole forces. Okay, boleh? Boleh tak?
Boleh.
Okay, so kalau saya lukis, so hydrogen is more electropositive ke arah chlorine. So, since kalau you tengok, chlorine is way more electronegative than hydrogen. So, dia akan lagi banyak electrons. Dia lagi banyak negative charge. Wouldn't it be tertarik to another hydrogen from another molecule? Sebab hydrogen ni pun elektron dia semua dah ditarik oleh chlorine. So, dia macam very positive. While this chlorine dah tarik banyak electron from this hydrogen, dia become very negative. So, what happens is this attraction will arises. That's why we call dipole forces. The force between dipole moment, of one molecule to another dipole moment of other molecule. So the keyword is not the same molecule. So from contohnya this is molecule 1, dia akan tertarik to molecule 2 and also tertarik to molecule 3. Okay, that's why we call it dipole-dipole. Between this dipole moment tertarik and with this dipole moment. But I really want you to highlight it is only for polar molecule. Kalau CH, will it be tertarik to another CH? Kita dah tahu tadi CH is non-polar. So it will, dia takkan tertarik, so dia tak ada dipole-dipole. Dia tak ada dipole-dipole. Tapi kita akan see dia still ada other forces. Okay, so now let's see. So that's the dipole-dipole. So what does the effect of dipole-dipole forces? Okay, because kalau you tengok tadi, some of the molecule are more electronegative than others. So a more polar molecule, can you guys salin this? Dekat tepi yang ada tempat kosong tu, dekat you guys punya buku nota ke, salin. A more polar molecule, okay, and it is higher electronegativity difference. Tadi kita tengok electronegativity difference ada yang sampai 2, ada yang electronegativity difference dia only 0.8, ada electronegativity dia dah 1 point something. So the higher the difference, okay, the higher the difference, the stronger the dipole-dipole forces. So macam contohnya carbon and fluorine is very high. So lagi tinggi electronegativity difference, lagi kuat lah the electronegative elektron tu tarik elektron. Sebabkan electronegativity difference is high, so the positive one is very weak, the negative one is very strong, so dia tarik banyak. So they will create a partial negative and partial positive charge, the stronger one, rather than kalau just different dia sikit. Kalau sikit tu macam dia nak tarik sikit, but this one still kuat, so dia still boleh tarik sikit dekat dia punya atom, so you wouldn't have a stronger dipole-dipole force. So kalau ada stronger dipole-dipole force, more energy needed to overcome the strong dipole-dipole force. Okay, bayangkan yang model saya tunjuk tadi tu. Okay, lagi kuat the forces, ibarat lagi kuat velcro tu. So lagilah banyak energy saya kena bagi to the system untuk break the molecule apart. Between the molecule A and molecule B, saya nak break dia apart. Between HF1 dengan HF2, saya nak break those. I have to put more energy. So lagi tinggilah temperature kalau saya nak boil sebelum dia orang jadi gas. Okay, so the boiling point increases. So the general idea is the more polar molecule will have stronger dipole-dipole forces, thus higher boiling point. Okay, boleh tak? So siapa sini yang pernah masak spaghetti?
No.
You nak masak spaghetti tu, you kena letak garam kan?
Yeah.
Yes. And garam, we have NaCl, Na plus and chlorine minus. So those are quite electronegative element. The chlorine is quite electronegative. So by that then we are making the water a bit more polar. So that's why kalau you tengok you letak garam, even though dia tengah boiling, you letak garam, dia akan stop boiling. So you need to naikkan api untuk bagi dia boiling balik, kan? So the more polar molecule, the stronger dipole-dipole force, the higher boiling point. Okay? Contohnya propane and acetaldehyde. So propane is gas yang guys guna untuk masak tu. Acetaldehyde ni jaranglah kita guna. So kalau you tengok, kita nak compare dia, kita compare dia punya molecular mass. Kalau molecular mass kita compare around the same, kita boleh anggap dia orang around the same size kalau molecular mass dia sama. And kalau buku dia akan, ataupun soalan dia akan bagi dalam bentuk dipole moment. And kalau you ingat, dipole moment is QR, and kita bagikan dalam unit debye. So kita wakilkan dalam unit D. So maksudnya kalau the higher the value of D, it means you have higher electronegativity difference. Okay, so kalau you tengok, acetaldehyde has debye moment of 2.7 while propane has 0.1. So kalau you tengok from this, kita can conclude that polarity of acetaldehyde is higher than propane sebab dia has higher dipole moment. Thus, acetaldehyde has stronger dipole forces, dia tarik even stronger. Thus, sebab tu lagi susah nak boil dia. Lagi tinggi temperature dia in Kelvin. Lagi tinggi, lagi banyak kita kena bagi energy to that system. Lagi banyak kita kena bagi energy to that system untuk boil acetaldehyde rather than propane. Because kalau you tengok, propane actually dia, kalau normal temperature, room temperature, it will exist as gas. Sebab tu you dengar kalau orang pergi camping, orang bawa propane gas, butane gas kan, dalam botol kecil tu. I think kat DIY ada jual. Okay, because absolute zero is -271.3 ke kita ingat. Nak tukar Kelvin ke degree Celsius, saya tak sure this one. Okay, so that's why propane is very easy untuk boil. Okay, everyone are following the lesson?
Yes.
Okay, I think London forces kita akan masuk hari Khamis.
London.
Yes, very cool. It's just that, okay, I'll give you one thing lah. Dipole forces ni for polar molecule, and tadi saya cakap CH pun ada juga attraction, tapi call lain. So for non-polar, kita have London forces. So kalau you buka you punya buku, dipole tu you tulis untuk polar, London untuk non-polar molecule. Okay, tomorrow kita Thursday kita akan tengok how London forces work. Okay, boleh?
Okay.
So, do you have any question? Okay, so far so good. So, since so far so good, I want you guys to do tutorial lah. So, macam tadi saya dah cakap, pasal chapter 6, you guys buat sendiri and check sendiri. Is more of a cara nak jawab je. You guys tengok cara nak jawab, you guys absolutely can ace that chapter. Chapter 2 is easy. Dia cuma ada dua benda je, effective nuclear charge and shielding effect. Everything you cerita based on that. Untuk chapter 7, start buat tutorial for 7.1 sampai 7.2. Sekarang kita tengah belajar pasal 7.3 kan, which is the intermolecular forces. And some of the question I dah bincang dalam kelas. And if there still question arises, text me. Kalau I free, I'll help you out. Okay, so just do it sampai 7.2 and then 7.3 kita maybe akan bincang later, maybe next week. Okay.